earlier. And really we focus on graphing y equals mx plus b equations, so pretty straightforward and basic equations. Today, we're going to learn about another way that we could write linear equations and how to still be able to graph linear equations when they're not initially solved for that y term. Okay, so another way to write a linear equation is in what is called point-slope form. Okay, this equation has advantages to it since it can use any point on the line, not just the y-intercept used in slope-intercept form. Okay, so slope-intercept form is what we are used to. We'll zoom in here a bit. So slope-intercept form is our good old y equals mx plus b, with m representing our slope and b representing our y-intercept. Okay, point slope form. Okay, if you notice there's 3 blanks. One of them is the exact same and it's in the exact same spot right in front of x, and that is m. So our slope still is the value right in front of x. Okay, but the other thing, notice that instead of intercept for y-intercept, we now have point. Okay, that point is going to be one of the points your line goes through. So like the point x1 comma y1, just like we use in our slope equation, and we plug the x value of that point in after x and the y value of that point in after y. So m is still for slope, x1 is x value of point, y1 is y value of point. So let's practice using some of the stuff that we did with last class notes. So write an equation for the line that goes to the points 2, 4 and 4, 10. Okay, so first things first, we need to find slope. So 2, 4 and 4, 10. 2 to 4 is going to be plus 2. 4 to 10 is going to be plus 6. Change in y over change in x, so m is equal to 6 divided by 2, which is equal to 3. Okay, so we have our slope. Okay, the second thing is we just need our points. Now, if you notice, we have 2 points. It doesn't matter which point you choose. Both of them will work. I personally prefer to just pick the first point. Okay, so our first point, remember, all of our points are x, y, so this is x1 and y1. So then we're going to plug our slope, our x1 and our y1 into our point slope equation. So y minus y1, so minus 4, equals m, our m is 3, so 3, parentheses, x minus x1, so 2. And that would be our answer. So notice the same slope we got here, we plugged in for m, and then I just picked my point 2, 4, x value went after x, y value went after y. Okay, and the equation has the subtraction signs. If either of my x or y values were negative, a negative and a negative makes a positive. So like if I had y minus negative 4, that would become y plus 4. Okay, so let's look at another example. So number 2, write an equation for the line modeled by the table. So as we've done before, okay, we need to do change in y over change in x. So negative 4 to 8, that would be plus 12. 8 to 20, that would still be plus 12. 5 to negative 1, that's minus 6. Negative 1 to negative 7, that's minus 6. M is equal to change in y over change in x, so 12 over negative 6. So m is equal to, 6 goes into 12 twice, and then it's positive and negative, so it's still negative, so negative 2. Okay, now as far as our x1 and y1 goes, remember with the table, a table is just like a bunch of x, y points. You can pick any of the points. I typically pick the first one. So x1 and y1. Okay, so I have x1, I have y1, and I have my slope -2. So from here, plugging into my equation, y minus y1, so y minus -4, okay, equals slope of -2, so -2, parentheses, x minus x1, okay, so x1 is 5, so x minus 5. Right, now I talked about this in the last one. Okay, if we have minus a negative is the same as a positive. So just to rewrite it so it's a little prettier, y plus 4 is equal to -2, x minus 5. Oop, wrong one. And that is how we write linear equations in point slope form. Okay. Same thing as slope intercept form in terms of the final result. It's still the same equation. It's just written a little bit differently. And we're going to see here in the next that we can take any point slope form and we can actually get it into slope intercept form. Okay. So the only disadvantages to writing equations of lines not in point slope form is that it can be more difficult to graph these equations. Okay, this is why when we need a graph, we can convert any linear equation into slope intercept form by solving for y first. Okay, real quick, this should be slope intercept. There we go. So we can get any equation into slope intercept form by solving for y first. Let's practice this process of solving for y and then graphing. So let's look at number 3. So we have -8x plus 2y is equal to 6. Okay, if we want to solve for y, that means I want to get y by itself, which means I need to move everything else in the problem. Okay, so for this one, before I can get rid of that 2, I got to move this -8x to the other side. So to undo -8x, I'm going to plus 8x and plus 8x. Okay, cancels out over on the left. Over on the right, 6 and 8x are not the same kind of term. So I end up with 2y is equal to 6 plus 8x. Notice how I did not add the 6 and 8 together because 6 and 8 are not the same kind of term. Okay, now I can deal with that 2 in front of y. I undo multiplying by 2 by dividing every term by 2. Okay, once again, over on the left, 2's and 2's cancel out. So we get y is equal to 6 divided by 2 would be 3. 8 divided by 2 would be 4. So we have y is equal to 3 plus 4x. Now, just to finish it off, this isn't slope intercept form now, but it might not be the easiest to read. So we can take any series of numbers like 3 and 4x, and we can just switch them in the equation, still on the same side. So this is the exact same thing as saying y is equal to 4x plus 3. Okay, and that now looks like our y equals mx plus b, which is a lot easier to graph. Okay, let's look at number 4. Okay, number 4, we have y minus 1 is equal to -3x plus 7. Okay, so this time we have parentheses. And if you remember from the beginning of the year, what do parentheses always mean? Parentheses always mean to distribute, and it should be the first thing you should do if you can work with those parentheses. So we're going to take our -3 and we're going to distribute it to both of our terms inside the parentheses. Okay, everything else is going to stay the same. So over on the left side, we still have y minus 1 equals -3 times x is equal to -3x. Negative 3 times positive 7 is equal to negative 21. Okay, from here, I can get y by itself. There's only one thing that's still hanging out with y. It's that negative 1. So to move it to the other side, I want to add 1 to both sides. Okay, notice how I'm adding it to the 21 and not to the 3x. That's because 21 and 1 are the same kind of term. They're just those constants. Okay, so negative 1 and positive 1 are going to cancel out over on the left. Negative 21 plus 1 would be equal to negative 20. So we have y is equal to negative 3x plus 20. Okay, notice again how we are now in nice y equals mx plus b slope-intercept form. And that is always our goal, to get in slope-intercept form. Okay, so let's step it up a notch. Let's now not just solve it, let's solve it and then actually graph. Okay, so on number 5, we have y plus 3 is equal to 2x plus 4. So first things first, we're going to solve. So once again, I have a number outside my parentheses that I'm going to distribute. So I distribute 2 to both. So y plus 3 is equal to 2x plus 8. Okay, from there, I need to move the 3. So minus 3, minus 3. Remember again, I'm subtracting the constants because they're the same kind of term. So y is equal to 2x plus 5. Okay, so now that I'm in slope-intercept, I can use my slope and my intercept to actually get those terms for my graph. So y is equal to 2x plus 5. So plus 5 is my y-intercept. My slope is 2, but remember, to make it easier, we can change any whole number to be that whole number over 1, so 2 over 1. Okay, so I'm going to put my y-intercept at 5 right there. And then I'm going to use my slope to get another point. So my slope is rise of 2 and run of 1. So I'm going to go up 2, run by 1, and that's where I'm going to put my next point. That's a really fat point, but y'all get the idea. All right, once I have my 2 points, I can then add in my line with arrows on the end. Just like so. Arrows and arrows. Okay, so some things to notice. We have a positive slope, so as we go left to right, our function should be increasing. That makes sense. Our function goes through 5, which is our y-intercept, and our slope has that up 2 over 1 for our rise over run, which is consistent. Okay, so much easier to graph once we get into slope-intercept form. So anytime you have an equation that's not in slope-intercept form, we just need to solve for y first before we can graph it. So let's look at number 6, and this will be our last example. 2x minus 5, y is equal to 10. So the first thing I need to move, just like last time, would be that 2x, so minus 2x, minus 2x. Notice 10 and 2x are not the same term, so I am not subtracting them. 2x and negative 2x cancel out. So I'm left with negative 5y equals 10 minus 2x. Okay, now I need to get rid of that negative 5, so I'm going to divide everything by negative 5. So that leaves me with y over on the left, because the negative and the 5 cancel out. Okay, 10 divided by negative 5. We're not going to get the negative to cancel out, so we still have negative. And then 5 goes in the 10 twice, so that would be negative 2. Okay. Then here we have negative 2x over negative 5. 5 does not go evenly into 2, so we're still going to have that 2 over 5. But our negatives are going to cancel out, so we do get positive 2 over 5x. Okay. Now, just like last time, okay, This is slope-intercept form, but we can switch the two numbers so it's easier to read. So I can switch this to be y is equal to positive 2/5 x, and then minus 2 for my y-intercept. So my slope in this case is 2/5, and my y-intercept, my b, is equal to -2. So now for graphing purposes, once again, I still start with my y-intercept of -2, so -2 down here at the bottom. Okay, this time, I already have a fraction. I don't need to do anything fancy. I just need to know my rise and my run. So I'm going to rise by 2, so 1, 2, and then I'm going to run by 5. So 1, 2, 3, 4, 5. And that's where we're going to put our second point. And then I can add in my line. Just like that. Doesn't have to be perfect, but you want it to get pretty close. And then arrows and arrows on the end. Okay, that is graphing lines when their equations are not solved for y. Okay, if you have any questions, please ask your teacher in class, and good luck on the stations today.